Good day, everyone. Today, we are going to discuss the general types of intermolecular forces. And at the end of this session, you must be able to discuss the general types of intermolecular forces and determine the intermolecular force present in a substance or in a compound. An activity will be given to you by deciding what intermolecular force is present in a compound or substance that will be given to you after the discussion. But before we proceed to the discussion of the different types of intermolecular forces, let's have first the definition and differentiation of an intramolecular force and intermolecular force. Okay, from the word intra, meaning within or inside. So the word intra means within or inside. Now, this means that intramolecular forces are forces within a molecule as they hold molecules together. Now, it is the covalent bond inside the molecule. So, I repeat, the intramolecular force is the force acting within or inside a molecule, and it is actually the covalent bond. It is the covalent bond inside the molecules. So, the keyword for the intramolecular force or intramolecular forces is the word inside or within. It is inside the molecule itself. Okay, how about the intermolecular force? Now, the intermolecular force are forces that form between. So, the keyword here is between. For the intramolecular forces, the keyword is inside or within. For intermolecular force, it is the word between. Between molecules, between atoms, or ions. Now, they hold solids and liquids together, and these intermolecular forces or weak interactions control many critical properties such as boiling point, melting point, vapor pressure, surface tension, viscosities, and viscosities. Now, the stronger the intermolecular force, that means the higher these properties also. Kung mas malakas yung intermolecular force, mas mataas din yung value nitong mga properties na ito. The relationship between these properties in a substance or in a compound with their intermolecular force is directly proportional. Meaning, kapag mataas ang intermolecular force, ibig sabihin, mas mataas din yung value ng mga properties na to. Let's have the hydrochloric acid as an example. Now, the bond between H atom and Cl atom is where the intramolecular force is. So, if we are going to connect the H atom and the Cl atom, that's what we call the intramolecular attraction. The bond between the H atom and the Cl atom is the intramolecular attraction or intramolecular force. It is actually the covalent bond. The covalent bond between the H atom and Cl atom inside the hydrochloric acid molecule. Now, the intermolecular force is the attraction. The intermolecular force is the attraction between a Cl atom and an H atom of two different molecules. So, kung sa intramolecular force, iisang atom lang yung tinutukoy, dun sa intermolecular force, meron kang dalawang molecule, at least dalawang molecule, at i-connect mo yung isang atom from the first molecule and another atom to the second molecule, given that the positively charged doon sa isang atom is connected to the negatively charged doon sa isang atom. For example, dito sa hydrochloric acid, dito sa unang molecule ni hydrochloric acid, the negative chlorine will attract the positive hydrogen of the other hydrochloric acid molecule. So that's the difference between an intramolecular force and an intermolecular force. Now, I want you to remember that it is always that the intramolecular force is stronger than the intermolecular force. Now, let's have the H2O comparison. Let's have H2O molecule as our example. For the intramolecular force between the H atom and the oxygen atom, the intramolecular force, you need 927 kilojoule per mole of energy to break the bond or to break the covalent bond or the intramolecular force between the H and atom. So you need 927 to break the intramolecular force acting within this molecule. For the intermolecular force, you just need 40.7 kilojoule per mole of energy to break the bond between the H atom of another molecule of a water and the oxygen atom of another molecule of water. So, mas malakas si intramolecular force kaysa kay intermolecular force. Ibig sabihin, mas madaling paghiwalayin ang isang molecule ng water sa another molecule ng water kaysa paghiwalayin yung H atom sa O atom ng nag-iisang water molecule. Now, since our study focuses on the general types of intermolecular forces, let us then keep our focus on it. So, intermolecular forces are responsible for the condensed phases of substance. So, nang dahil kay intermolecular force, meron tayong solid, liquid, and gas. Solids and liquids will not exist without the intermolecular force. Thus, intermolecular force are really responsible for the phase changes. And among the three phases, solid matters have the strongest intermolecular force acting on it, while gas has the weakest intermolecular force acting on it. Of course, as compared to liquid and solid. So, lagi niyong tatandaan, si solid ang may pinaka-malakas na intermolecular force. Strongest intermolecular force, weakest intermolecular force, si gas. Now, let's see what happens to the intermolecular force during a phase change. So, what happens to the intermolecular force if a solid turns to liquid? Kapag ang phase change ay melting or fusion, the intermolecular force is decreased. Bababa siya. Bakit? Kasi si solid, compact siya. Compact yung molecules niya. Now, kung pupunta siya sa liquid na mas disperse yung molecules, ibig sabihin yung IF mo, yung intermolecular force mo, magdi-decrease din. How about liquid to gas? From liquid to gas, alin ba ang mas compact? Liquid, mas compact ng kaunti yung molecules niya, yung orientation niya, while the gas, masyado nang disperse. So, the IF, the intermolecular force, will be decreased. From gas to solid, so from less compact to more compact solid, the intermolecular force will increase. From gas to liquid, so mas compact ang orientation ng molecule ng liquid phase natin kaysa sa gas, the intermolecular force is increase or it will increase. From solid to gas, from more compact to less compact, the intermolecular force will decrease. And from liquid to solid, so from less compact to more compact solid, the intermolecular force is increased. Now that you know the concept of the intermolecular force in general, let us now proceed to the discussion of the general types of intermolecular forces. Now, there are four main types of intermolecular forces. We have the London dispersion force, the dipole-dipole interaction, the hydrogen bonding, and the ion dipole. The London dispersion or the LDF and the dipole-dipole and the hydrogen bonding are all within a bracket of what we call the van der Waals forces. Ganon talaga yung spelling ng one, V. Baliktad siya. V, babasahin mo, yung van, one ang basa niya. Tapos yung W, magiging V yung basa. Kaya kung babasahin nyo to, hindi siya van der Waals, it's van der Waals. So, within the bracket of the van der Waals forces, we have the London dispersion, dipole-dipole, and hydrogen. So, ang ibig sabihin lang nito, magkakapamilya tong tatlong to. And the strongest among these four is the ion-dipole interaction. The London dispersion forces are forces that exist in every type of atom or molecule. So, sa lahat ng atom or molecule, merong London dispersion force acting on it. Pero, si London dispersion force, mas predominant siya sa mga non-polar molecules. Mas nakikita siya sa mga non-polar na molecules. Now, let's have an example. For example, we have here a non-polar as we already know as we all know, these electrons are in constant motion. So, ibig sabihin, gumagalaw lang sila ng gumagalaw. Now, there will come a point na while these electrons are moving within this atom, may point sa orientation ng mga electrons na nasa iisang part nasa iisang lugar lang nung mismong atom, yung mga electrons. Nakakoncentrate sila sa iisang area doon sa atom. So, yung isang side ng atom magiging partially negative, tapos yung side na walang masyadong electron magiging partially positive. So, ang tawag na natin sa atom na to, non-polar atom to, hindi non-polar molecule, non-polar atom. So, magiging tawag na natin sa atom nito is an atom that is polarized temporarily. Ayan. So, magiging resulta niya, magkakaroon tayo ng partially negative sa side na to, partially positive. Meron tayong tinatawag na temporary dipole o induced dipole. Remember na itong dipole na to, or yung pagkaka-orient ng mga electron sa loob ni atom na nagmo-move, ay temporary lang. It's not permanent. Now, what happens to this temporary atom or temporary induced atom? Ito na yung result ng temporary induced natin or induced dipole natin. So, ito na siya. Our temporary dipole. So, we call this our dipole atom. Remember, na temporary lang yon. Now, what if there's another non-polar atom surrounding it? So, merong maitatabing, for example, meron siyang na-encounter na isang non-polar atom ulit. So, i-attract niya, ang gagawin niya, yung mga electrons dito sa isang non-polar atom, i-attract nung induced dipole natin, nung induced dipole atom natin, i-attract niya. So, it will attract, thus it will produce, so makakaproduce siya ng partially negative, partially positive, partially negative, and partially positive Remember na opposite attracts. So, si positive lalapit kay negative. So, this is our dipole. Ito yung dipole atom natin. Yung nauna kanina. Tapos, ito na yung in-induce niya na dipole. Ito yung original natin na atom kanina na dipole atom. Yung naunang result nung kaninang sinulat ko. Ito na yung na-induce niya. Ito na yung pangalawang atom na tumabi sa kanya at nagkaroon ng induced dipole. So, ang induced dipole ay a temporarily short-lived. Hindi siya nag-stay forever. So, the attraction between these two atoms, the dipole and the induced dipole atom, is what we call the LDF. So, nandun si London Dispersion Force. Nasa gitna ng isang dipole at isang induced dipole. Induced dipole, ibig sabihin, it is created by another dipole atom. So, this induced dipole is actually created by this dipole. Kaya siya tinawag na induced dipole. Itong pangalawang atom. So, si induced dipole, ito siya kanina. Ang tawag mo dito ay dipole atom that is temporarily induced. Okay. So, that's how the London dispersion work between molecules or atoms. Now, we proceed to... So, para mas maintindihan natin ang LDF, mag-ano pa tayo ng ibang example. So, LDF is actually dependent on the number of electrons. Take note, dependent siya on the number of electrons in an atom. So, kung ilan yung electron dun sa loob ng atom, nakadepende yung force or lakas ni London Dispersion Force. Now, I have said a while that the London Dispersion Force is predominant in nonpolar molecules because nonpolar molecules are or have more electrons than polar molecules. So, they have more number of electrons than the polar molecules. Thus, they have greater LDF or London Dispersion Force. So, that's actually the relationship between the electron number, the nonpolar molecules, and the London Dispersion Forces. Now, let's have iodine and fluorine as an example. So, iodine has 53 electrons. While fluorine has only 9 electrons. Now, as you can see in our diagram, since iodine has more electrons than fluorine, therefore the iodine atom is larger than the fluorine atom. Remember that the more number of electron, the larger the atom. So, the more number of electron in an atom, the larger the atom. And that means that that atom is more polarized. So, kapag mas marami siyang number of electrons, mas malaki yung atom, plus mas polarized siya. More polarized. Kasi, more polarized kasi nga, mas malaki yung nadidistort. Mas maraming electron yung nadidisturb o nadidistort. Kaya, more polarized. So, that's it. The number of electrons and the size of an atom and the polarizability of an atom are directly proportional with each other. And, of course, the LDF also increases with an increase in polarizability. So, mag-i-increase din yung LDF force mo. So, kung mapapansin nyo, directly proportional lahat from the number of the atom, the size of the atom, the polarizability of the atom, and the force of the LDF acting on that atom. So, kapag mas mataas yung value ng isa, sasama yung iba na tataas din yung value. Now, let's have this set of atoms. We have helium, neon, argon, and krypton. Now, if I am going to ask you which of these molecules have the greatest London dispersion force, of course, you would answer krypton kasi nga, kung makikita nyo, dito sa table natin, the number of electrons in krypton is 36, which among these four, it has the greatest number of electron. That means krypton is the largest atom among dito sa apat na pinag-uusapan natin. Ibig sabihin, mas greater din yung polarizability niya, greater din yung London dispersion force niya. Now, if you're going to look at the boiling point, if we are going to relate the London dispersion force of an atom to the boiling point, it is also directly proportional to it. If the LDF is great or greater, the boiling point also is greater. So, negative 153 as its value of boiling point for krypton is greater than the negative 269 boiling point of helium. So, uulitin ko, kung mas mataas, kung mas marami yung number of electrons, mas mataas yung LDF. Kung mas marami yung number of electrons, mas greater yung chance ng polarizability, mas malaki yung atom, and greater din yung boiling point or higher yung value ng boiling point of that atom. So in summary, the more dispersion forces, the greater the dispersion forces that a molecule has, the greater the boiling point will be. And as the number of electrons within an atom or molecule increases, the boiling point of the substance will increase due to the increased amount of intermolecular force, specifically the London dispersion force. Now try to answer this activity. We have here fluorine atom, chlorine, bromine, and iodine. Fluorine is in a gas phase as well as with chlorine, while bromine is in liquid phase and iodine is in a solid phase. So based on the number of electrons given, determine kung alin sa molecule na nandito ang may highest London dispersion force. And based sa phase niya, phase meaning if it's solid, liquid, or gas, determine kung alin yung strongest, aling molecule yung may strongest London dispersion force acting on it. So, isang atom yung isusulat nyo dito, yung sagot niya. Answer this, yan, which, based on the electron number which has the highest LDF and based on the phase which has the strongest LDF. So, kung kanina, nag-focus tayo sa non-polar molecules, kay dipole-dipole interaction naman, this force exists between molecules that are polar. Polar, ibig sabihin, ang polar molecule, meron siyang permanent na dipole. Ang ibig sabihin ng dipole, meron siyang dalawang side, meron siyang dalawang pole. Yung isa, positive, yung isa, negative. Partially positive, partially negative, I should say. Now, substances with dipole-dipole interactions tend to have higher melting or boiling point as compared to the non-polar molecule which only have LDF. Now, this means that when we are going to compare the force of the dipole-dipole interaction with LDF, when we are going to compare the force of dipole-dipole interaction with LDF, mas malakas ang dipole-dipole interaction kaysa sa LDF force. So, tandaan nyo lagi, mas malakas ang dipole-dipole sa LDF. Let's have hydrochloric acid as an example. So, in our previous lesson, we determined that hydrochloric acid is actually a polar molecule. So, paano siya naging polar? Kasi meron siyang dipole. Kung makikita nyo, the H side or the hydrogen side is partially positive while the chlorine side is partially negative. So, meron siyang dipole and it is a polar. Meron siyang permanent na dipole, it is a polar. So, when two molecules, so isang molecule ito ni HCl, pangalawang molecule to the HCl. When these two attracts each other, we have an attraction that is called a dipole-dipole. Dipole-dipole siya kasi yung isang molecule may dipole, yung another molecule na nag-a-attract sa kanya, merong ulit dipole. Now, that's the dipole-dipole interaction. As you notice, lagi ito sa loob ni hydrochloric acid molecule, naka-attract yung positively charged sa negatively charged. Ngayon, kung itong isang buong molecule ni HCl, makikipag-attract doon sa isang molecule ulit ni hydrochloric acid or HCl, yung negative ng isang molecule, i-attract niya yung positive ni isang molecule. Thus, like charges repel, and unlike charges, attract. So, ito yung sinasabi lang nung law na ito. If opposite charges come together, they attract. And if the same charges, they repel. So, kapag positive pinagtabi mo, magre-repel. As well as negative, magre-repel. Pero, kapag positive at negative ang pinagtabi mo, they will attract. Now, let's try to see the relationship between the dipole-dipole interaction and the boiling point of that given polar molecule. In a dipole-dipole interaction, an increase in a polarity of molecule, kapag magi-increase ang polarity, magi-increase din ang dipole-dipole interaction, mag-i-increase din ang boiling point ng molecule na yon. So, makikita nyo ulit, directly proportional yung relationship ng polarity ng isang molecule sa dipole-dipole interaction. Oh, shucks. Sa dipole-dipole na interaction at sa boiling point, which is the property of that molecule. Now, consider the four molecules we have here. Propane, the CH4, the second one, we have dimethyl ether, and then acetaldehyde, and then acetonitrile. So, if we are going to look at the boiling point, ang may highest boiling point, syempre, makikita natin sa arrow dito, increasing polarity. That means that the boiling point increases from left to right. So, the molecule that has the highest boiling point in these four given molecules is the acetonitrile. And of course, syempre, ang weakest or the molecule that has the lowest boiling point value is the propane. Bakit? Kasi siya yung may pinakamababang polarity among these four. So, kung mababa yung polarity ni propane, mababa din yung dipole-dipole interaction niya, mababa na rin yung boiling point niya. So, yun yung relationship ng polarity sa intermolecular force and sa property of the substance. Now, we have the third intermolecular force. We have the hydrogen bonding. Ang hydrogen bonding, madali lang i-determine. When a hydrogen atom is covalently bonded to nitrogen, oxygen, and fluorine. Kapag ang hydrogen nakaband dito kay nitrogen, kapag si hydrogen nakaband kay oxygen, kapag si hydrogen nakaband kay fluorine, we call it the hydrogen bonding. So, for example, sa water molecule natin, si H nakaband kay oxygen. Yan. I'm sorry. So, for example, sa water molecule natin, hydrogen bonding ang tawag natin dito kasi it's a bond between an oxygen of another molecule to the hydrogen of another molecule. So, ito, isang molecule na to ni water, another molecule ni water, another molecule ni water, and another molecule ni water. So, kapag nag-connect-connect yung mga molecules na yan, meron kang intermolecular force. Meron kang intermolecular force. Pero, since we have here a bond between an oxygen and H atom of another molecule, specifically, the intermolecular force acting on this molecule is the hydrogen bonding. Ayan. Hydrogen bonding is actually the result of high electronegativity of nitrogen, oxygen, and chlorine. Matataas kasi ang mga electronegativity ng value nitong tatlong atom na ito. Kaya, hydrogen bonding is the intermolecular force acting on this molecule. And the fourth intermolecular force, or the last one that we are going to discuss, is the ion-dipole interaction. The ion-dipole interaction is a stronger type of electrostatic interaction, and it is in fact the strongest intermolecular force among these four that we are discussing. Now, this is the strongest. Okay. Now, they are important in solutions of ions. We have here an example. We have NaCl. So, this is your salt. And we have here H2O, which is your water. Now, ang nangyayari kapag nagdi-dissolve ka ng water, ang nangyayari kapag nagdi-dissolve ka ng salt sa water, ay yung Na ion, ito yung Na ion natin, ina-attract ni oxygen, which is slightly negative to itself, and the Cl, the ion that is negatively charged. Ang ion kapag positively charged, ang tawag mo doon cation. Ang ion kapag negatively charged, ang tawag mo doon anion. Okay. So, si Cl na negatively charged, ia-attract ni hydrogen doon kay water molecule that is partially positive. So, this is actually what happens at a molecular level when you dissolve salt to water. Remember that NaCl is a polar molecule and H2O is also a polar molecule, thus solidifying the idea that we have said before that like dissolves like. So, ito yung explanation kung bakit ang polar molecule ay nadidissolve sa isang polar molecule ulit at ang non-polar molecule ay hindi nami-mix or nadidissolve sa polar molecule. In summary, we have all weak intermolecular forces called as the van der Waals. Der Waals forces. So, ito yung sinasabi ko kanina. Tatlo sila. We have the dipole-dipole interactions, London dispersion forces, and the hydrogen bonding. And lastly, na hindi na kasama kay van der Waals is the ion dipole and the strongest intermolecular force. Yan. Now, to guide you to determine or how to determine what intermolecular force is present in a given molecule or ion interaction, let's have the summarized map of the intermolecular forces. So, ngayon, ang titingnan mo, meron bang mga ion? Para ma-determine mo sa isang atom, ion or molecule kung ano yung intermolecular force na present, tanungin mo muna, meron bang ion? So, ano bang ion? Ion, yun yung may charge na atom. So, for example, Na positive. Yan. Cl negative. H positive. So, kung yan, tatlo. Na positive, Cl negative, H positive. Basta may charge yung atom mo, ion yun. Ions. Okay. If there's no ion, you ask again, is it a polar molecule? If it's not a polar molecule, if it's a non-polar molecule, then dispersion force, yung intermolecular force na present or intermolecular force present is the London dispersion force. Hindi nyo kakalimutan. If the LDF is the present intermolecular force, therefore, non-polar molecules yung involved. Ngayon, kung ang sagot mo, yes, there are polar molecules present. So, dalawa lang pagpipilian mo dyan. Kapag polar, it's either dipole-dipole interaction or the hydrogen bonding. Yan. Polar to. Polar molecules yung kaakibat nitong dalawang to. Pero ang titignan mo na ngayon, kung ang hydrogen ay naka-attach sa nitrogen, oxygen, o fluorine, under siya ng hydrogen bonding. Pero kung ang molecule ay polar, parehong may dipole na may permanent dipole, then it's under the dipole-dipole force. Now, let's see. How about if there are ions present? Present ang ion, merong polar molecule. Ang magiging force mo is the ion dipole. The ion dipole. Bakit? Kasi it's an interaction between an ion and the dipole. Ion, yan yung may charge na atom. Dipole, yan yung molecule na merong dalawang pole. Most probably, isa siyang polar molecule. Okay, I want you to, since tapos na yung discussion, I want you to answer these questions based on what you have learned dito sa discussion na shinare ko. Now, here are 4 questions to check your understanding, to assess your understanding dito sa concept na tinakal natin, and another set of 6 questions for the conceptual check. Titignan ko kung naintindihan nyo. Yan, screenshot nyo na lang, pati yung nauna kanina, balikan nyo na lang din. And lastly, ito yung performance activity ninyo. Ang gagawin nyo lang, just follow the direction, just fill out the boxes provided. So, first, draw the Lewis structure. So, dito kayo magdodraw. Wait. Dito kayo magdodraw. Next, determine if there is a permanent dipole moment in the molecule. So, determine nyo kung polar o non-polar. Siyempre, kung polar, meron siyang permanent dipole. Kung non-polar, wala siyang permanent dipole. Yan. Now, is the molecule asymmetrical? Titignan nyo rin yung drawing. Magbe-base kayo sa Lewis structure dito sa number 2. Magbe-base kayo. Asymmetrical ba si molecule or symmetrical? Ganyan. And next, identify the strongest intermolecular force present. Identify the strong intermolecular force present. Okay, so dito kayo magdodrawing. This is where you draw. This is where you write if there is a dipole moment. This is where the intermolecular force is. Itusulat nyo, mamili kayo sa 4 na intermolecular force na pinag-usapan natin. So, Mr. Wade did the other molecules sa question, ganun din ang gagawin ninyo. Just fill out the blanks for this performance activity. So, 4 lahat to. 1, 2, 3. Tapos kanina, sa gitna-gitna ng video natin, nagbigay din ako ng activity ninyo. Sa London Dispersion, merong activity doon. So, yes, you may submit this activity until tomorrow, Tuesday. I hope you learned from this session, from this video lesson. Until next time, ganito na naman. Hopefully, natututo kayo sa ganitong way. Now, if you have any other question, just ask it sa ating group chat.